Alright, Assalamualaikum. Continue from the previous video. Now we have general problem. Alright, so here let's consider two complex number. First complex number we denote by z equal to x plus yi, and then second complex number denoted by z1 equal to a plus bi. So if we present it in Argand diagram, we can put it generally. We put complex number z is here, so we denote as z equal to x plus yi, and then another point, for example, is put z1 is over here, so z1 equal to a plus bi. And we have learned also before this, we can find the distance between these two complex number by using the modulus formula or Pythagoras theorem, and is also known as magnitude of complex number. So how we find it? How we can find it? So basically we can have modulus of z minus z1 is equal to square root of x minus a square plus with y minus b square. Right. So for y, this is formula for general problem. Now let's see example. In question A, we have modulus of z minus complex number 2 plus 4i and equal to 3. So think about it. Generally we have complex number z, and particularly we have a complex number 2 plus 4i. So geometrically over here, the distance between complex number z and complex number 2 plus 4i is or must equal to 3. So first, in order to see that, better for us to rewrite this equation into a circle equation. So as we know that modulus sign over here can represent by square root of x minus 2 square plus with y minus 4 square. That's how we find the distance, and the distance here must be equal to 3. If we square both sides, we will get the circle equation: x minus 2 square plus with y minus 4 square equal to 3 square. And this circle has radius of 3 unit and center at coordinate of 2, 4. Basically we can also write in complex number the center as 2 plus 4i. We actually can get it from here. This is the center actually. Alright, so now let's sketch it. So referring to this circle equation, we draw the circle. Real axis, imaginary axis. So first we need to locate the center. So the center is 2, 4, 1, 2, go up by 4, 1, 2, 3, 4. So here is the center, where the center is 2 plus 4i. Okay, now we need to draw the circle with radius 3 units. So 1, 2, 3, 1 2 3 over here, 1 2 3 over here, 1 2 3. So connected all these 3 points, we will have a circle of radius 3. What it means, same as we have in the first video. Basically, the complex number z that satisfy this equation lies on the circumference of circle, where we know that the distance from complex number z to the center is 3 units. So this is represent complex number z, x plus yi. Right. Hopefully you understand with that example. Alright, the next example is modulus of z minus 3i less than 4. Alright, so if we want to write in full equation, we can write it as x plus yi minus with 0 plus 3i less than 4, and we want to find the modulus or magnitude of these two complex number. How we find it? We can find by using the modulus formula or magnitude formula or the Pythagoras theorem formula. So square root of x minus 0 square plus with y minus 3 square less than 4. And if we square both sides, we will have x minus 0 square plus with y minus 3 square less than 4 square. Alright, so now we can imagine that we will have a circle that has center at 0 3, or we can write in complex number as 3i, and the circle also we can imagine has radius of 4 unit from the center. Alright, so how we sketch it? We can sketch it first the axis. Real axis, imaginary axis. First we need to locate the center. So the center is again 3i, so 1 2 3. So here is the center denoted by 3i, and then next is we need to draw the circle with radius 4 units. So go to the right by 4 units. 1 2 3 4, 1 2 3 4. Go to the left also 4, 1 2 3 4, and go up also 4, 1 2 3 4. So we just connect all the point that we mark. And again, back to the previous video, this is less than sign, so means that what we need to do is we need to have dotted line of circle. And again, this is less than sign. What we need to do is we need to shade the region in the circle. That means the complex number z must lies within the circle only, but not on the circumference of circle. So geometrically you can think that any locus point that lies within circle, the distance is always less than 4 unit. Alright, hopefully you can understand this example, and you can also try example 11.15 in the textbook for question C. Alright, thank you. Alright, so for the detail of sketching of locus, please always refer from your textbook, from page, you can see from page 288 until 292. Alright, thank you very much.